Okay, in this video, the objective is to be able to understand and use factorial notation. So basically what factorial notation looks like is a number with an exclamation point. And this exclamation point is the factorial notation, and this means basically it's the sum of that number minus 1 and minus 2 and so on. So for example, 5 or sorry, not the sum, but the product, right? 5 times 4 times 3 times 2 times 1. Of course, it's not times 0 because that would just give us 0 every time. But 5 factorial is the product of this multiplication. 5 times 4 times 3 times 2 times 1. So the 5 factorial, the product is 60. Okay. And one way that you could use this, for example, is like, let's say you wanted to find the order of, well, okay, let's say 6 people run a race, and how many different ways can 6 people finish a race, and all 6 finish, okay? Not how many different ways can the first 3 people out of 6 finish, that's something else, but how many different ways can 6 people finish a race? So in that case, we could use 6 factorial. And basically what we're showing is that in first place there can be 6 people, right? So you're running a race, or 6 people running a race. In first place, any one of those 6 people could cross the finish line first. But once they cross that finish line first, now there's only 5 people left running the race. So there's only 5 options now for second place. And then after the first 2 people run across the finish line, there's only 4 people for third place. And you see this pattern. After the first 5 cross, there's only 1 person that's in last place. The glare is really bad. But 6 times 5 times 4 times 3 times 2 times 1. And I think you get 360, if I'm not mistaken. So 6 factorial would be 360. So that's one way you see factorial notation. And then another place you will see factorial notation is when you're solving permutations and combinations. Sometimes you have, for example, 10 factorial on top, and let's say you have, after you simplify, let's say you have, let's say 8 factorial on the bottom, just for example, right? So we know that 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? And 10 factorial is 10 okay, 10 times 9 times 8 and so on, right? So we could do this the long way and then see that the 1's cancel and the 2's cancel and 3's cancel and so on, all the way we get up until 8 factorial. Then we're left with 10 times 9 on top, which gives us 90, okay? A faster way to do that is to have 10 factorial over 8 factorial. That's 10 times 9 times 8, and then we're just going to leave this 8 as 8 factorial over 8 factorial, and then we can just cancel these a lot faster and get 10 times 9 in the same answer as 90. Last but not least, especially when you're going to permutations, you'll see maybe the question will be 12 factorial, and then you'll have 12 minus, let's say 12 minus 9 factorial, and again you solve this same way you do other math, parentheses first. 12 minus 9 is 3 factorial, and 12 factorial, this will be a long one, 11, 10, 9, 8, 7, 6, 5, 4, 3 factorial. Then the 3 factorial cancels, and then you could put that into your calculator. Although for scientific calculators, there's a faster button for those types of problems. But anyway, that's a couple different places. That's what factorial means, and that would be one. Again, sometimes if you don't have that scientific notation button for the permutations and combinations, then you can do simplifying factorials and make the math a little bit easier for you. So that is, hope that was clear, and I thank you for watching.